Welcome back everyone to the Hello World Guide. This is another episode of the Android game development series, and in this video we are going to figure out the delta time in our game, and we are going to make a basic ball system. Add the ball component of our game, but currently we are not going to do inter-object collision, just main collision. So to create the ball, I'm going to just copy and paste the player one for the the player game object, and then I'm going to rename it to ball for the tag, and then we are going to change its size, and the color I'm going to just make it white for now, for example. And here we are going to change of course the behavioral functions here. So for example, the first thing that we need to do is we will add another property here for velocity of the ball, since the ball is going to be moving. Actually we'll add it down here, so we'll just add a single vector for now, which we'll call velocity, and this will represent the direction as well as the magnitude of what direction and with what magnitude our ball is moving. But later we are going to actually just split it up into direction and speed separately to make it easier to work with. And here we are going to just add state.delta time with self.velocity multiplied by self.velocity to our position. Now of course this delta time currently does not exist, so I'm going to go in our game and we are going to add a float delta time here. And of course we need to actually get this data from somewhere, and we are going to actually move it after our camera. And here I'm going to go ahead and go under game.h, and inside of here for the update function we are going to make it take delta time as a parameter, and in main.cpp we're going to add that. But first let's fix that in the cpp file, game.cpp, and we are only going to fill this in the update because it's irrelevant for the touch event. And after doing that we are going to go ahead and inside of this loop we basically want to figure out the logic for handling delta time. So delta time is basically the time spent between frames. So we are going to first of all create a variable called last, which is initialized to the current time for the first instance, and then we are going to go ahead and copy this and just fix some formatting here. And we basically want to measure the time that is spent in each frame. Then we need to convert that to a float, and we need to pass that to our game update function here. So to do that we are going to go ahead and first of all make another now variable, which is set to again the current time, and this is going to be a current time updated each frame. Then we are going to set the delta time, which is going to be now minus the last time, and then we are going to set our last to now so that it's updated for the next frame. And then we are going to get our delta time float value by getting the we are going to do a duration cast to convert it into seconds. So we are going to do std chrono duration cast, and then for the duration value we are going to say std chrono duration, and you must pass float here so that it actually takes the floating point value for the seconds. And then we are going to do that for delta, and then use dot count to get the numerical value of it. And once we do that we can just go ahead and pass it in the end as dt here. And yeah, that's pretty much it. So we are going to go ahead and now add a velocity value to our ball, and for example we can just set it to 0 on the x and -1 on the y, so that the ball starts by going down. Of course we are going to add collision later, so first we are going to add that. And if I go ahead and run that, what you should be able to see is that we get a ball in the middle of the screen which starts moving downwards eventually. So you can see that the ball is created here and it is moving downwards correctly, and this is of course it currently does not interact with anything, but we'll add that soon. And the next thing we will do is we'll start by first of all we are going to take our velocity and we are going to split it up into a separate direction and a speed, so that our speed is independent and we can just change the direction vector and normalize it without having to worrying about the magnitude. So we are going to make the speed separate, and we are going to change this to be direction. And for the when we are actually using this, we are going to take self.direction multiplied by self.speed multiplied by the state.delta time. And for the speed we are going to just set it to, for example, 1, just what it was before. So yeah, we have got that here, and this is going to get this to work correctly. And now the next thing we need to do is we need to in our update function we need to actually handle collisions between the wall and other parts. For example, the first thing we are going to do is we are going to make the ball interact with the screen boundaries so that it can bounce off the screen boundaries. So we are going to just go ahead and check if our self.position.y is less than the state.camera.bottom, and of course we'll need to add the half size to it. And we are going to actually when we are comparing this, we need to compare the position.y, not the whole position. And another thing is that after we do that, we need to also make sure that we are actually moving downwards. The reason we need to do that is because if we flip our direction and we are actually moving upwards already, then that will cause the ball to get stuck. We don't want that. So we are only going to flip the direction if we are moving in the wrong direction. And if I go ahead and run that, you can see that hopefully we get our ball and it bounces off the bottom of the screen. So as you can see, yeah, it does that. A small mistake is that we need to actually divide this by 2. We were not doing that earlier, so we need to make sure that we use the size, and we need to use the y size here. It doesn't really matter because both are same, but if we decide to change it in the future, it's better to use the correct value. And we're going to have to do the similar thing for all 4 axes. And now technically most of these you could have these two in a single statement using a logical or operator, but that would get a little messy, so we're going to just keep it separate. And with this it should be able to go ahead and go ahead and bounce off all of the 4 corners of the wall. And for that I'm going to try by, first of all we are going to try a direction of 1 to test it horizontally, and then we can try a direction of 1 on the y to test it vertically. So if I go ahead and test it horizontally, you should be able to see is that the ball is moving correctly. Yeah, you can see that the ball is moving left and right correctly. I increased the speed so that it's a bit easier to test, and you can see that the bouncing is functioning. And now we are going to change this on the y-axis, and now you should be able to see that the ball should go up and down correctly, and as you can see that is working. So yeah guys, this is our ball, and you can see it's interacting with the walls, but it's currently not interacting with either the paddle or the bricks. So the next thing we need to implement is the interaction with the paddle and the bricks, and that is what we are going to be doing in the next video, which is going to be out soon. And after that our basic gameplay is going to be done, so we are going to do some final touches, replace these boxes with some sprites maybe, and then we'll have this game completed. So yeah guys, this is going to be pretty much it for this video. I'll see you in the next one. Make sure to like and subscribe as well, and share this video with other people, and bye.